effect on it, but some of it is just going to be.
Did that change to Arial? It looks like it did.
Yeah, it did.
Those bottom that detail at the bottom just kind of mess things up.
Yeah, pretty much.
But seems like there's not much we can do about that.
No, because there's not a lot of settings for these reports. They're pretty.
We can't scale it up to an architectural E1 or even a.
Nope.
Really?
I guess you could, but depends on what kind of printer you have.
Or not an E1, like a tabloid.
There's tabloid, yeah, sure. Just most everybody has.
Yeah, I mean that's
just most everybody just has a regular copier printer.
Yeah, tabloid's not bad. That's,
okay.
That's better.
I cleaned it up. That's for sure.
Units here?
What's that?
Can we change the units for this stuff?
Well, it's pretty limited to what we could do.
I mean, can you change it to just 7 foot, like with the markers, or no?
Hang on. I think you can. Let me see where it's at. Oh yeah.
Oh, I found it.
There it is. Yeah. But you can't enter it that way. Just so you know.
Yeah. Will that only display when I print it?
There you go.
But why does it have both dimensions? What are the difference? Oh,
one is the panel dimension. One's the cumulative.
Right.
If you don't want the cumulative.
Why is it changing the cumulative to that other format?
Yeah, go back to that. See where it says cumulative PL?
Yeah.
You can do panel length, pitch break, which means it's only going to put dimensions in. You want panels on there for the shop drawings because that's how they know where to put them at.
Yeah.
That way they can measure from one end and mark them off.
Yeah. Okay.
But in order to show the screw counts on, you got to turn them on your screen also. So you have to go view, screw count, and then you got to reanalyze it. The analysis, the results are not saved. So if you leave the truss and come back, you got to reanalyze it to print.
Do I have to print every single truss?
Yes.
There's no batch print?
Maybe say what now?
There's no way to batch print?
Oh yeah, you can do that. You got to go to the batch tool that you analyze all the trusses with. There's a function in there to print with.
Oh, okay. But there's no way to batch print with all the screws in there?
You got to turn them on screen first. You got to reanalyze them first. So add everything. Tell it to add all. Down on here, see where first it had to be analyzed and saved. So you can tell it to print drawings without analyzing or just print drawings. Over here on the click on print drawing.
And then run batch?
And then run batch. Well, click the print drawing one. The other one gets a little weird sometimes. Oh, that's working good. I've had people have problems with that.
Except that it's literally printing every single truss by itself.
Right.
Is that the only option?
Yes, we don't have any way to combine them. And yes, it drives me crazy too, because yeah, I'll leave it at that. I'm not gonna sit here and gripe at you guys about it.
Well, I guess as long as the engineering works.
Yeah. It has its quirks. I'm not gonna lie about that.
Oh my goodness, this is gonna take me a day. All right. Cool.
Okay.
What's next?
Now, all right. So there's another tool I haven't shown you yet. It is called VersaTruss. You get to it by double clicking on any piece on the truss. There's a button up there for it. But this tool for you guys is the tool of last resort. If you can't get something to do something, this is how you're going to be forced to do it. So you have to pick a member first. As soon as you go in there, it removes all stuff. It's just what it does.
Sorry, what? It removes all what stuff?
It takes away all the changes that were made in analysis. Yes, another complaint I've griped about for a year. I don't know why, but that's what it does.
Okay.
So how this works, this has got 3 sections to it. Okay. The left-hand section is you can select a member, you can draw on the list, and they're not in any particular order. Okay. This is how you would add new pieces. You had a top chord, a bottom chord, a web, or a reference line. Okay. Top chord, bottom chord, web, reference line. This is how you would select a member and click the steel button. It brings up this and it tells you you can change the piece, the size of the piece or anything, or if you change it, or you can make it go back to the default for the material type. And you can also tell it, I want to fix the size, don't make it larger, or I don't want the gauge to change. And then what is it analyzed as? You're not going to mess with that too much, just because it could.
So, what is the purpose of this tool, VersaTruss?
Okay, so this tool, the purpose of this tool is to manually add or manipulate lines or members.
Got it.
Okay. You can also tell it to remove a piece from here by clicking remove, whatever you have highlighted. Okay. Everything in here is based on a series of lines. All right.
Everything in the software you're saying is based on a series.
Everything in design, yeah. All the way the truss is put in here is all based on a series of lines.
Yeah, they're all vectors, right, of some sort.
Yeah. There are some hard-coded ones that you're not allowed to change the line at all. And because that's basically, it says, well, here's how it defines the shape. You can't change that line. You would have to add another one to fix it. So, all right. So you have different types too. So you may have to start adding reference lines so you can put another line in. All right. So like that's what RL is for, is to add a reference line. That all it does is help define something else. Excuse me. So now you have different definitions for these lines. Okay. It automatically, like when you pick reference line, it defines the parallel. But you can hit the drop down, and there are multiple kinds of lines. Pick. So you can do parallel, point, slope, which is what most chords are defined as. Point slope is I got a point and it has a slope emanating from that, and it has an offset to set the heel height with. So if you click on the top chord real quick, click on T, just you can go over, click cancel, and then click on T1. There you go. So T1 has point slope, but then above that has how it's defined. So you have C is center, U is upper or right, depending on how it's oriented, and L is lower or left. What side of the line, whenever you put the line in, how is the member going to fill off of that? Okay. And then the next part is its intersection. Where does it start at? What's its slope? That's the pitch. The over 12 is implied. And then the offset, that's the heel height. So it's saying from that intersection, raise up the offset of 7 inches. So 7 inches above that, that's where this line's going to start. Okay. You're not going to use this too much. So I'm kind of just showing you some stuff. And anything you have to change, if you change something about a member, make sure you check the box to save member modification or it'll lose it. Another one of my pet peeves.
Okay.
And then in this section over here is the end cuts area. What lines is that member cut at? So you see 2 numbers, okay? There's an imaginary line that represents right and left running down that. So you're allowed 2 cuts on each end. So the line it's cut at on the top end is A42. At the bottom end, it's cut at overhang left. There's a predetermined line called OHL. So if you added an overhang back on, it would know to just extend it automatically. So yeah, so if you want to, now if you made a mistake and cut that again, so you have to do each side by itself. You can't move around, otherwise you'll get that. So you're gonna want to hit cancel. As long as you don't hit OK, it won't save it.
Got it.
So this is one of those things that you kind of have to tinker around with, but you shouldn't really have to do a whole lot in it.
All right.
The profile tool should help you get the webbing the way you want it. And if you really get stuck, we'll go over the situation and I'll get in there and help you use this a little bit better, you know, to get what you want. Because I could spend a day on that tool, literally. I have in the past. I've spent 4 or 5 hours teaching somebody how to use that thing. Just because getting the concept down is can be, and all the stuff it can do. Okay. Let's see. Let's make sure I'm not forgetting something now. Oh. So now you saw those tools up there. There's buttons. If you right click in the white space anywhere on the truss, All those tools are available on the right-click menu. So bracing, edit steel, flip. The edit steel, if you click on that, pick a member, you can just, instead of going to Versal Truss, you can edit it here. Then hit enter. Oh, no, hang on.
Yeah, no, I edited the wrong thing.
Hit that, click that, hit enter.
Not doing anything.
Oh, right click again, sorry.
Okay.
Then you can edit what that piece is. You want to delete it, you can delete it.
So it's important to save a truss every time you make changes, correct?
Yes. Yep. Analyze it, save it. And then that way, you can always go back to it. So there's a lot of stuff that's got, you know, yeah, there you go. So it's a lot faster to use the right click tools than go find the button, but not all of them have it, are in the right click menu. The ones you're going to use the most are.
Excellent. Will and Tiago, do you guys have questions or something you want to see?
Yeah. I think we're at that point.
I'm good right now. We're taking recordings of the video, so we'll probably, I'll probably need to go over and watch them again and take more notes. Yeah, there's a lot to it. We'll take a little bit. Can't say I've caught on as
there's a
fast
lot
as
to
you, Mateo.
process. You know, yeah, there's a lot going on. Yeah, Will said the same thing. Same, there's a lot taking a lot in. Yep, I agree. So
if I hit import all here, will it update any trusses that were changed?
yes. The best thing to do would be just pick the ones you know you changed and then import selected.
Okay, so like.
It's faster.
Right. Let's see. Let me make that one a 2-ply real quick and see what that import
Yeah, sure.
looks like.
Huh? What happened? How'd you get there? Oh, it crashed. Why did it crash? Or does it seek something wasn't analyzed? It's all got check marks on it. Yeah, change it back to USC. And then analyze, yeah. Okay. All right. Oh, hang on. Load at joint AI exceeds the core capacity for transfer to second ply. It wants you to add a joint at that point. That's what it's asking you.
Where is AI? A to I? This
17, 1, and 2, so it's probably over here on the left or on the right. So click yes. Yeah. That brings it. Okay, now I know why I brought it up. So click on that. Click on the bottom chord. You tell it to add a joint. All right. Select one of them. Probably the one like that one. Change that number to match where they wanted you to put it at.
I don't remember what it was.
Yeah, that should be close enough.
It's pretty close, yeah.
Like build. And then it'll finish. Click OK. Yeah, and there's the problem. Is that why didn't it work? Wait a minute. Why did it work before? I'm confused. It worked the first time we did this.
So it's still failing.
Yeah, it's got a load transfer problem at joint K. There's too much force at that point. It worked a minute ago. Yeah, that's weird.
Hold on, I'm gonna take a call, but we can switch.
All right. All right.
What is the mechanism for, so if some truss is like more than 40 feet, you can't put it in, transport that all together.
Oh,
What's
okay.
the mechanism
So
for joining trusses?
to put them together. Well,
Like, well, you create two halves, right?
you could create two halves and just screw it together in the field. Steel, you can get away with it that way. I've heard of people doing it. You don't even have to put a scab in it.
It's just like a simple connecting piece they use.
No, you just set it up to where there's a splice where you want it reconnected together at. Build the truss in parts and come out with it. You can do that if you want. A lot of it depends on if you've got interior bearings, you want to use them and split the trusses on it. So if you go back to well, that's a scab, so you don't need that.
It's saying there's too much force here?
Yeah, you could do that too, yeah. But
Will
it's going to
that-
want to put one in each ply.
Oh, so that won't work very well.
Probably not.
Ooh.
Yeah, it made it worse. Just say no.
All right. Well, for the sake of, I would like to see it re-import. So let me add some more webs to this one and see if I can get it to re-import.
Okay.
Was Tiago trying to check something?
Yeah.
I just had a question about splicing two trusses together. Like
Well-
if it's really long.
Well, I mean, really long depends on how long you can ship. Mostly you just put it in, you have it on the table, put it together, but just don't screw it together in certain points. And then when they get it in the field, then you screw it together where it needs to go. The only problem with that is trying to keep it square in the field.
Yeah, in the past we've assembled it and just left the screw holes, and then we take it out. So then they just line up those screw holes.
Oh, there you go too. Yeah, that's another thought too. That's a good idea. It's much different. You can't do that with wood. You gotta have these giant scabs and all kinds of crazy stuff to get it to work. Huh? Oh,
I know it doesn't need two plies, but I'm just curious to see what it imports in like.
yeah. Make sure you save it.
All right, I'll save that one, and then I'll
Then
go,
go back. Yeah.
and I should be able to
I would
just.
say that the procedure you're doing before would work.
Okay, so now it looks like that two ply.
Yeah.
Got it.
like I said, other things you can do is because you can't really make it split. That's the thing, unless you're going to make two separate trusses. That if you have another, if you have a bearing they can, a beam they can share, that works pretty good. Also, if you because there's a tool to split a truss on a location in the software. It's in the steel engine roof roof trusses section. Under tools, there's a drop down to split the truss. It won't be in here.
Oh.
It's in steel engine. So
Oh,
if you
right.
go back
Right.
to steel engine roof framing, go to tools.
Brake
There's a
truss.
brake truss. Yeah. So brake truss, it splits the truss into two parts, and you'll pick a line you pick a truss, and then click on a line where you want to break it at, and it'll make two separate trusses in that point that are parallel with each other.
Gary,
Uh-huh.
we had a couple drawing questions that we had questions about. So, one is dormers, and the second is low slope roofs with facades on the front of them.
Like parapets.
Yeah.
Well, you can't put the parapet in steel engine. You have to just change the end vertical type in that would be the thing you got to use VersaTruss for, is
Oh,
put a
okay.
line in where the here, let me show you real quick. Say this piece, not that. C5. Say this piece is our parapet,
Right.
for the sake of argument. All right.
Yeah.
So what you have to do is come in here, have a line representing where you want to cut it at. So
let's use one of the lines that's already there.
no, well, I was going to show you how to put one in. So
Oh, yeah. Show us how to
say you
put one.
want one 6 feet up from the bottom. Common thing. So you pick reference line, it's parallel, and you come in here and find the bottom. You can pick the bottom of the truss. And then you'll see things in here like C4 minus. That's C4 minus is the lower edge of it. And the back distance factor is going to be 6 feet. Then I click OK, and now I have that line in. Or it must be over here. And it zoomed out too far. I don't know where my 6 feet's at. Oh, it's up here. There we go.
Okay, from C4.
It's up there. Okay. So now I would pick this piece here, not that one, this one. And I have two end cuts. Well, this one's telling me that this is cut to the upper edge of the flange on the bottom cord. So it says B1 sharp or hashtag, which anytime you see the hashtag, that represents the edge of the lip on the material for the cord. Okay. So I know I can't change that one. So A31, see it highlighted here. So then I would come up here and I highlight this, and then I come up here and then I click on the line I want it on to replace it. If you don't click in the radio button, it will just add a new end cut. Since this is the one I wanted to edit, I clicked in it and then I clicked another line. Okay. Once I've accepted that, I click OK. Now I have to go to the top cord because I got it to get it to stop doing that. And you would tell it its end cut stops at the end of the parapet. So it extends through. And that's what you have to do.
Okay, and does this software analyze the parapets? Or would we have to?
You have to add some load to it. You would
Okay.
have to go into you have to go edit loading and roof. Then in the wind load, make sure that you had end vertical turned on so it knows that the wind's blowing at the end vertical.
Oh,
And
that's an end vertical.
that's an end vertical, yeah. Cantilever at the bearing was back here. This would be cantilevered. You have to turn cantilever on so it knows the wind blows underneath it, up against the bottom cord there. But in order to get the full load on the parapet, you have to add a point load up here, of which depends on what the EOR is telling you to do. So it would put a load blowing at it, but you still have to put some kind of load up here with but you have to do it in the let's see, concentrated. Wind external. Point to the right. If load type exists, and then it's distance. Okay. Oh, I think well, yeah, I know you didn't. Oh, I don't know what it's going to be. Doesn't really like adding loads up there, so I thought there was something else you had to do, but don't. It may be that you have to make it a uniform load going to the right of
But that's technically not the top chord, right? It's
it's a web, but it's actually analyzed as a top chord.
Oh.
This is a bad example, put it that. But you do have to turn on the end vertical to make sure the there we go. If I do chord segment, I can apply it to the whole thing. I tell it to probably I got to put something at the top. That's the kicker to this.
So sometimes your engineering team has to do some work for bracing, is it? So what does the work cover?
Say that again, please. I'm sorry. They have to do work for what?
What does your engineering team have to do whenever we say have them do the works?
Oh, the works. They go through every connection of the truss one at a time. They figure the bracing out for the entire building, specify all the connections. They give you all the information, like I said, there's bracing, there's They check all the they stamp all the trusses. As far as I know, they stamp a bracing layout for you. And I can't remember what else they do.
Okay, so that's important to know. Is bracing layout not automatically generated, or is it?
Correct. If you ask for us, you have to add. You can ask for a bracing layout by itself, but when you ask for a works package, make sure you send the layout in, because they'll yell at you.
So what does this software here doesn't give you the bracing layout then? I thought it did.
This doesn't, but hang on. This does. So we have it all in here. If I come in here and do automatic bracing, this is where you're going to get some. It's going to tell you which trusses you're going to have to go and what members you're going to have to go in and modify the bracing on. If one of these comes up and it's a gable truss that tells you that, just ignore it. Okay, because those get it's not smart enough to know the truss is a gable. It doesn't need it doesn't know what kind of bracing to put on it, I guess. We just click close. Down here. There's all our web and cord braces. A couple things we didn't go over yet are, come on, I'll hide sometimes. Schedules. We have a bracing schedule. You select everything you want to add to it. Hit enter. Then then it's going to show you what the bracing is going to be. So you're going to click, place it, and then you're going to drag a box out. Of course, I didn't drag a big enough box out. So now I got to do this. You can move it around too by clicking in the middle. So if you mess up and let go before you want to, you can always click a grip on the corner and drag it to make it larger. And then you can grab the center and move it around.
Okay. So, but that's not sufficient. Or is it case dependent? Are there some cases where clients say we want the bracing engineered as well?
It depends on who's in. Yeah, I don't know. That I'm not all up on what the requirements are. Some people just want them so they can hand them to the whoever's doing the installation and go, here you go. Here's where all the braces go. But we have customers who do both. So once they get that, then they know what to put in, but they have us check it to make sure it's right. Just to double check it. Not saying it should be wrong at any point, but you having an engineer look at it and verify that everything is right. Okay. We also have truss schedules where you can put a list on. Works the same way.
Okay. And the other modeling question we had is, how do you put a dormer in?
Well, the dormer is a little trickier because you have to put the walls in where they go, and then you have to put the planes on the walls and intersect them where they have to be at.
Oh, okay.
And then place trusses on. There's not a tool for it. One of these days we may have it.
So in that schoolhouse job, they have small dormers, just kind of random small dormers.
Right. So you'd have to add walls, or Yeah, because you got to have some kind of bearing. So you'd have to add beams or something where they're going to go. And then put planes on them and then put the trusses on them. But we don't have a dormer feature.
So you just have to model a little roof on top of your roof.
Yeah. Yep.
Will it know to intersect with that other roof?
If you tell it to. When you're doing the manual cut roof edge, one of the lines could be in the existing roof. So
Right.
it shows the valley line properly. Yeah, no, it's not hard to do. As long as it's not sticking up too tall.
Can we,
As long as it actually intersects it.
can we draw a dormer, just a dormer?
Yeah,
on
go
this
ahead,
one?
draw. Just draw on a
So-
couple walls. So you want to go to add a wall, pick a point someplace. Yeah, so make a wall, just make it go up like, there you go. All right. Now you want it to be right, you want it above the roof though. Because if it's sticking up, that one may not be. Yeah, go ahead and put those in.
Real quick, let me. My goodness. Like in this scenario, let's see how they have their dormers drawn. The dormer is drawn right on the hip, and this
Yeah, you
one.
can do that, sure.
Well, let's do this one here. This one's drawn on the, just on the slope. So we'd put that elevation.
Because you have to know how tall those are going to be. Otherwise, it's not going to do anything because it's going to be under the other part. So you'd have to go in and say base height and change the base height in the properties.
All right.
We'll say, we'll make them 13 feet. Okay. And then scroll down.
Hold up one second. I'm trying to
yeah.
get a view of this one over here.
Oh, well, actually, I should have had you do that a little bit different here. So instead of base height being 13 feet, what you can do is say your base height like 6 feet or 5 feet, or make them 3 feet, just for the sake of argument, okay? Then go down to elevation, change the elevation to 10 feet.
Right. Okay. So that pops it up there.
That pops it up, and you don't have to have that giant wall there.
Okay.
And then you would put planes on that. The only thing it doesn't like, I don't think you can rake them. No, that's just it.
What do you mean?
Where they'd be on an angle.
So like this one probably doesn't have walls underneath it. Maybe only the front has a wall.
Well, it's got to have something on the side, or else it doesn't have anything to set on.
Oh, okay.
They probably extend out, and just for simplicity's sake, you put them in the squares, and then the rest of it just sits inside the building.
Right. Okay. So okay. For simplicity's sake, you model it kind of halfway into the roof.
Yeah.
Okay, and then I want to add
A roof edge. The one there. You wouldn't put one there because that's coming back out.
Right.
That's okay. You can hit there. Then you'd want an additional one. Then you would have to put a wall in the front of it.
Okay.
To represent the gable end. But you don't necessarily have to do that.
Okay, I can do that later. So then let's say
So that one, then you manually cut the roof edge. You'd pick that one. And the second cut would be against the back roof. Yeah. and then against that plane. Yep. And then just pick the wall just so it looks right. Yeah. And then hit
Okay.
enter. And hit done. Do the same thing the other side. Oh, hang on, hit back.
Yep.
There you go.
Well.
Yep. Hit done. And then done.
All right. So now I have.
Now that backs up and corners the valley into the roof.
All right. And then I would just draw trusses kind of right here.
Yeah. And then if it was big enough, you could put a valley set in if you wanted to, but
A valley
depends how
set
much
right
bearing
here.
you have. You know, it could be something they have to frame in because it's not that big.
And would that automatically bear on those roof trusses there?
No, it's going to bear on those walls. Maybe these trusses that you're going to put in are going to bear on these walls because there's going to be walls sticking up. Hopefully they get kind of bearing going down.
But like in this example, these are just, I imagine these are just on the roof. Like they're not, there's nothing underneath them.
Oh. Okay. If that's the case, then
It's just
I mean, you
decorative.
oh, okay, I follow you now.
Well, it's decorative and it has fresh air for AC system, attic ventilation.
Right.
It seems like something they should site frame a good bit of it.
You would think so. But you know, you could put it in your, in your bid and then get more if you got it, you got pricing in for it, then you're covered if they, it's easier to take it out than put it back.
Right.
If that's the case, you could make just simple trusses and you could probably get away with not putting any webs in something that small. You know what I mean? Which
Right.
would be just an open channel for them to use that. But if they were going to sit on the roof, what you could do, now that you have that, delete the walls. Planes will stay where they're at. So another thing you could do is add lines.
I could have just drawn lines, right? Okay, yeah.
Yeah, you could draw lines and put them at the height they need to be at,
Uh-huh.
and then assign a plane to them and draw it in that way too. It all depends on what you have to do. Some have walls there, and then in this case, if they're going to follow up the roof like that, then you would want to use the valley tool under roof framing.
Okay.
Say valley. So the support edge of the valley is going to be the plane at the bottom, the roof plane they're all sitting on. So yeah, that
one. This one here?
Yeah.
Wall or the roof edge?
Roof edge. Now it's going to go U and L, which you want the left edge. So that's the left side of the truss. Pick that one. Pick the right side.
This the right side?
Oh, no, the right side of the truss because the trusses are going to go across.
Right.
Yep. And then where do you want? Click the you would click the line where the first truss is going to go.
Well, should I do it on the left side? On this side?
No, because you want. Yeah, click that. then you pick wall because you want it to go start at that wall and then just click done. Now you may have to trim them a little bit, but we're gonna follow what that is all the way down. So you're probably gonna have to do ends adjust to make them have little overhangs and stuff on them, but that's not too bad. And it's only the first 3 that you have to edit.
So I would just drop. I can't get
You
this
would go
view.
through and cut the top cord to where the overhang line is and cut the bottom cord to the
Oh,
reference line you have.
okay. And then I would put like a little vertical piece here.
Well, you put an overhang on them. And then if you cut so in this case, go ahead and click on ends adjust. Oh, hang on. You want to, don't do that yet because that's the wrong line. So hit escape. Pick those 3 trusses.
Is there a third truss?
There's the 3rd truss. Yeah.
This one?
Yeah. It didn't put one at the front. Oh, there's probably an option. Hang on. Go to, before we do this, go from SE full model to roof framing. There you go. Pick on your valley framing set. Come over here, change the style. We should have did this first place. First offset, change that to 0.
Okay, so that
There we
added
go.
that other.
And then say that one is yes. Takes the first one to yes. Now the truss is there. It's supposed to be there. And that should be good. All right.
What is this
So-
little piece here?
That's in the front. That's up here.
Oh, there's like 2 trusses there.
It could be. Hang on. Oh, there's 2 there. Oh, okay. There's one in
Okay,
front of the other one. Yeah.
Just based
Right,
off
so-
the location of that little roof.
Yeah. Go ahead and click away from it. Oh, it put 2 there. Okay, never mind. I had you put a second truss that you don't need. All right.
So I can remove that girder truss.
Yeah. Change that to no.
But I could see how if the dimensions were different, we might need it there or something like that.
Right, exactly.
All right,
But
so
you
now
highlight the first 4, that one and the last.
do you
And
think this,
that one definitely. So you're gonna go to ends adjust. You're gonna pick and cut left top cord. That one there. Yep. And cut a bottom cord. It's gonna be the line that represents where the plane is.
okay, shoot.
Just say click no again. All right, there you go. Because you're doing one end at a time. Don't forget to pick that other one there. Yeah.
All right, so ends adjust. Top cord is here.
Gonna be the
bottom
overhang.
is
Yep.
here.
That one is the line.
Oh,
If
dang
you
it.
pick one. Just say yes. That's fine.
Just for now.
It's good for now, but you get the idea. Oh, why did it pick? Oh, that one's going to be different. Sorry.
Okay, yeah, that's what I was
That one's
thinking.
going to cut off on the roof.
Is that
yeah.
one fine how it is right now?
No, because it's going to be sticking out of where the.
Okay.
Just say yes.
All right.
Well, maybe it'll be okay. Okay. Well, it depends on how that's going to go up. If you look at it, it may be sticking out someplace, but you'll have to check that. It may not. It might be fine. Yeah. It's probably okay. All right.
They all look like they're sticking out. Will that be?
Well, they're all going to look at it. Yeah, it'll be fine.
It'll be fixed in design.
Yeah, that's just representation. When you bring it to design, it'll shrink them a little bit.
Right. It'll make them probably over here.
It'll fix that. Yeah, they'll be fine when they come out. So now you got to do the other side.
Okay.
And
All
it's
right.
got the right cut line on it.
And
There
so
you go.
that will give us kind of that wall effect.
Well, exactly. Yeah. You won't see it yet until you send them over, and possibly that last truss isn't even needed. But that's the
Okay.
procedure to put them in.
But that will not put any force on the trusses below it. Correct?
Well,
Will it? Would it
it
load
might.
those?
I'm not sure actually, to be honest with you.
Hold
If
on.
you
what
had
did-
trusses below it, you would have to have a truss below it.
what
Check
what do you-
connectivity. If it shows connectivity on those points, well, no, valleys don't show connectivity. I think it does know that there's load there.
how do I add the main trusses? Was that the full truss add?
Yeah, either one. Frame run's the easiest one to do.
And so I select the top edge.
Whatever. Yeah.
I select this edge first.
Yep.
I select the right edge.
Yep.
Start line.
Yep. And then where do you want it to end at? You want the wall, but that's close enough.
Yeah, yeah. I'm just trying to test connectivity.
So if you highlight all those, and then this is where you got to be careful. If you've already got stuff in, don't do it by current drawing or the other button.
Right.
You want it to do by selection.
Do I want to select the valley as well?
Yes.
Okay, and then I can check connectivity.
And then but you only want to do by selection
Oh, okay.
because otherwise it could screw up all your other trusses.
We don't want that.
No.
By selection.
Yep. And then now you can hit current drawing because it's only going to use those. Now it won't show connectivity on a valley to the truss below it, but we could probably check the loading file and it would tell us.
How do you check the loading file?
Yeah, once you send it recreates it when it sends it over.
Okay,
So you could
so
just send those over.
let me
First you got to first you need to label them.
label selected.
Yep.
Automatic only.
Now, if you don't want those other ones to be the same as the ones you have already, you could call them something else. They're
I think
T5s. I don't
I
think they're the
think
same.
Yeah, I don't think it did. So
Okay, that's good. So now you can send those over.
so I want to design selected.
Make sure design is closed first.
Design selected.
Yep.
So we want to go look at a T5.
Right. So just hit start. Okay. Just hit close. Then go to T5 first. Well, you're gonna have to design all the put them all on everything. Oh, you need to turn that off because it's gonna cause all kinds of problems.
What?
You got that detail turned on.
Right. That's fine though. I mean, not
It
fine.
should be okay.
Okay, it is
So you're
showing.
gonna have to analyze all the valleys first.
Okay, so it
So
is
if you
showing.
go to batch,
Right, right. And then we
all
just
you have
want
to do is pick the V's and the T5. That's all you have to do. But you got to do them one at a time.
Oh goodness. Okay. I was hoping. Oh my goodness.
Yeah, it's a little picky.
And it doesn't remove them from the list whenever you add them.
No, it does not.
That would have been convenient.
Yeah, I know. The web version of this doesn't do that either. So Now
Run
you
that.
should just be able to tell run batch, but make sure you're at the top.
Oh, okay.
Otherwise, it'll only do the last one. But some of these you're gonna want. Okay, click. Go ahead and close. These details are screwing it up. It doesn't know what to do with them.
All right, all right, all right. We can remove it from all, right?
You can, yeah, if you want. It's
Uh,
because it's adding to the bottom of the valley, so it's doing all kinds of weird stuff.
yeah. Basics, trust details, none. Okay, okay.
Then global change.
This button, global changes.
Yep.
Changes in trust detail.
Yep. So that's one thing you got to be careful about if you apply it to everything. It could, so now you can,
All right, now I can go run batch.
so, okay, so,
All right, bear
all
with
right,
me.
hang on. There's another way you can do that. So click close here. Now hit batch. Those are all added now.
Yep, run batch.
It's done.
Okay.
Why didn't it run those? That one's just a triangle. That one, not too sure about what. Go ahead and hit the heck happened. It won't let you analyze this thing.
But some of these are like, I don't know, I didn't analyze that one. These seem like they could be analyzed.
You'd think so. Oh, I know what's wrong. Anytime you have gables, it wants a diagonal in. So you have to go to the gable tool.
Where's the Gable tool?
Over to that one, you've passed it. You can also right click, go to gables, click OK. It needs a diagonal to keep it from racking.
Oh.
So then you can analyze it and say,
Oh. Okay, so all of these need gables.
yeah,
Oops. All right, I won't add it to all of them. Just interesting.
but that's how you fix it. Whenever it does that, you have to go do this.
Um.
So
Oh,
just
and then I
for
have to
the,
save it.
so
And then I have to save it.
apparently it doesn't put the load on it because T5 would have not analyzed if it needed the load from all of them.
Right.
So that answered that question. So if
Okay.
you wanted the load on there, you have to do it manually.
Okay.
Okay.
All right, that answers that question. So we have to load it manually. Would we just take the weight of all of these and kind of add it together?
You're probably going to do some kind of average or something because you got to put a distributed load across it. You know what I mean? I mean, you could put point loads for each one on there.
No, that's not what I'm thinking. But like, I
It
would.
seemed
But
like,
I was thinking like add all the weight of these together and then create some kind of distributed load.
yeah, but then you can do that and then figure out how long it runs and divide by that to give you the pounds per lineal foot. You know, if they all weighed 500 pounds between the three of them,
Yeah.
and you got to run across a 20-foot span, you just divide them into it. That gives you a PLF.
Yep.
Apply it. So yeah, that'll work.
Okay. I'm glad we're all engineers here.
Yeah, I'm not an engineer. I just been doing this for a long time.
Yeah,
I used to
yeah.
have to do crap the old back in the 90s. You had to do things, a lot of manual stuff. I took a class on how to do all that.
Yeah.
For like a
I'm just
week.
glad that my crew is engineers so that they Tiago and Will are both engineers so they can
Right. So that's good. That's helpful. So
All right. Well, that was kind of, I think, our big questions. Tiago, you can correct me if you had any other additional questions, or Will. And I'm sure we'll have more soon.
Oh yeah, no, I understand. I just fed you guys a lot in 3 days.
Tiago, Will?
Yeah.
Maybe they're asleep. Nothing now, haha. Okay.
Okay.
I'm
All right.
good.
Okay.
This was fantastic. Thank you so much, Gary.
Oh, you're welcome. Maybe you'll be able to understand me better next time I talk to you. Getting there. Although I got worse from yesterday to today, so that's all right.
So we're pretty good here. Oh,
Okay.
one more question. How do we generate a materials list out of this? Isn't there a way to
Okay. Okay. So you're
we
gonna
get
have
to
to
pay
look
extra
in
for that?
No, there's a tool that does that. You have to go into the no, my brain just had a blank. You got to go to the summary program. It gets installed automatically as part of design.
Oh, okay, yeah. Where is that stuff? Somewhere.
Summary. All right. Over here on the tree on the right, you're gonna go to jobs, or you're gonna browse to wherever you put the stuff at. There's the trusses. Down here at the bottom, click Add All. Click Project Info.
So I can
You can
enter
enter
all
in
that
project info in here, okay?
stuff. All right.
Once you have that done, click Done. Go to Material Summary. It'll tell you if there's issues, it'll tell you.
There's
Crash, stupid thing. It doesn't like if you can't, I would just say, don't put that.
Huh?
You can tell it shut down because it doesn't like when the truss isn't analyzed. Sticky. So you got to go back to summary. And actually all the trusses are, yeah, you got to go do that.
I figured I was just gonna analyze them.
Yeah, that's fine. But the only other thing I didn't do is go over how to do a outriggers.
What are outriggers?
At the end of the gable, the framing out, going out, forming the overhang on the outside of the gable.
Oh, right. Okay, yeah.
There's multiple names for them. For outlooker, outrigger, whatever.
We call them like a ladder truss a lot of times, or a ladder something.
Yeah, well, here, what it does is you do each side of the gable. You can only do it in each plane. I'll show you real quick. It takes a second to do one. But the program will analyze all that for you too. So in here, it's loading all that. So you have a material summary. There's a couple of things in here you can grab. You can also create a CSV file for them. And then when you're ready, you'll click Run Reports. It puts, you get to tell it where to put the CSV file. There's a place to tell it.
Okay.
It gives you all these material. It gives you the list of what all of it is.
Nice.
But to change pages is up here at the top. Okay.
Okay. Total
And
job
it gives
cost.
you total at the bottom. Okay. If you can print that if you're ready to print it. Okay?
Right.
Then you close it, click done. Okay. Then now you bring up quotation editor that has other. So in this case, you're going to tell it to use current values, so it'll bring everything in.
Okay.
Right. Then you're going to click the print button. Now you have all these other reports you can print. These are just previews, or you can just do a straight hard copy.
Okay.
Some of the material summary is in both places, but you can only create the CSV from the other one. But it has to go in these steps.
Did it save the CSV?
It did. It put it in not where you thought it was. We have to. I'll show you where to change that setting.
Run reports?
And once you're ready, click Run Reports.
Oh, yeah, that looks like, yeah, I've seen that from trust manufacturers. Yeah. And then it's got more pages.
Yeah, and at the bottom it gives you the total. Because now it gives you, there's a 20% overhead thing set up. So
good deal. All right. Okay, and it just made it. This makes those same reports that we were seeing earlier.
Right.
Okay, got it. That's a cut list. That's steel pull list.
Kinda. Yeah. Essentially, it is. Yeah.
Okay.
Okay. So a couple things. Yeah, you can click when you're done printing. You just hit exit. All right. So go to setup. Oh no, it's options. Sorry. Oh, now I'm having a brain fart about where that was at because I changed mine to a folder I wanted it to go in. Now I gotta remember. That's this. All this is doing is telling you where the tree to start at when you open this.
Okay, so that might be handy for me to change later, but
yeah.
Let's see.
Cancel.
Do I have to do it every single time?
Yes. This program doesn't store anything. All it does is generate reports based on what you entered. Oh, go to toolbar and then paths.
I think I froze the software.
Give it a second.
I'm impatient. Here. All right, let me get that job back real quick.
How did I do that? Hang on.
At all.
I gotta remember where I saved my my CSV files to. It goes to the oh, you can set where that goes. Oh, it just goes into your default folder. How do I change that? I'm trying to remember now. So the CSV file is going to go in your Aegis USA folder right now. So I got to figure out how to get that out of there.
That's fine. That's fine.
I've never changed mine. Now, there's also something if you guys are doing. So if you want to use the CSV file to help figure out your material list, also to optimize different material, you can.
Right.
But when you got to do your first order from us, those guys will help you out with that. Between Kevin and Dave Boyd.
Got
it. They'll get on and help you out to optimize your order, from us.
Okay.
Apparently I can't change where that goes. Huh.
You don't think that if I set the path to
Oh, that's going to be something different.
you don't
That's
think
just how.
you don't think I'll save the CSV to this file?
Oh, that's a good question. Hang on. Very good question. Send path to somebody.
Material summary.
I don't think. Yeah, I don't think it will.
Well, I managed to crash it again. Oh, well, at least it saved this now.
Yeah, that's good. So that way it'll be a little bit quicker for you. But you got to click through every one of those buttons every time you go through it.
Life is hard.
What's that?
Life is hard.
Yeah, I know. That's okay.
Oh, look, it did. It did save it.
It saved it in that. Oh, that it puts it into the default folder you start with. All right.
Yeah. Let's see. Let's see it. I'll believe it when I see it. Yep, there it is.
It'll be called material and the job name, so it won't be. It'll be easy to find.
Yeah, that's handy. All right. Is there anything else in this you wanted to show us?
No, I think we got.
So then let's real quick look at that outrigger.
Oh yeah. So what you're gonna do is go to steel engine roof planes or
I
roof
saw
framing.
it.
Sorry,
I saw it before.
outriggers up under between hip and valley.
All right.
Right. Outrigger. You're gonna pick one roof plane.
Like this?
Yep. So go over here to the style first. The new by object, and then what's the spacing of the outrigger pieces? The 2 feet's pretty good. The spacing direction is going to go from the eave up. The eave is the overhang on the truss
Right.
towards the peak.
Right.
Okay. How many plies is the outrigger going to be? One's normal. Do you want the peak outrigger to be there? Probably. And do you want one at the eave, which is down at the overhang? I would say yes to all that. And then right now it's going to drop the gable truss lower for these to come out. All
Yeah,
right.
that's two.
And then if you scroll down a little bit, yeah, that's, and then your rake fascia starting length, which is going to be the piece coming out here. 8 foot's probably good. Depends on your what kind of span you have. If being at 30 feet, 8 foot's not bad. Okay. And it's going to make sure it doesn't stick out of the overhang out front either.
All right.
All right. Okay, so now you're going to want to do this on 2D view to make it easier. You scroll in, so you're basically drawing a big box. So the eave is the overhang of the truss that it's the end of the overhang of the plane you picked.
Sorry, it's the end of the overhang.
It's the overhang line, not that one. That's the rake line. It's the overhang on that truss all the way out, that one. So you're going to pick the eave line. Setback truss lines. You're going to pick the front of the truss that the outriggers are going to connect to. Then you're going to pick the peak line. Because you can only do one side at a time. That's good right there. Then you're going to pick, hold on, didn't take it. Go ahead and click it again. Come on, just pick the first one. What's going on?
Peak line must be higher than the eve line.
It is higher than the eve line. All right, so hit back. Must have picked something else. All right, pick the target roof edge. Yeah.
Select the
there.
eve line.
Yeah. Now the eve line is going to be this overhang for that pit. Oh, you have to zoom out. Hang on. Oh, you got, okay, never mind. You're good.
Select
The peak line. Now pick the outer rake line, which is the purple line. That there. There you go. Oh, you went back. What?
Oh, I'm looking at it from upside down here.
Oh, okay. That explains why it didn't work. Okay.
I
And
don't
then
know.
you would do that.
I thought
That would explain why it didn't come out the way you wanted it to.
Why is it? Oh, it's upside down in this view. Oh.
Oh.
All right.
Okay. No, that's fine. That's why I
Oh.
told you the message.
I get the idea.
Then you would do it on the other side.
How come this doesn't extend all the way?
It doesn't need to. It's only there to support the ones down at the bottom that don't have any weight, don't have two.
Right.
It's down there to support that one mostly. So you could make that a little bit shorter if you wanted to.
That's the starting fascia, rake fascia starting line?
You can make that like 6 feet, should be good.
Okay.
Yeah, that's the only.
Um.
You have to do it on each. You have to do it on each side.
Yeah. Okay. So let me try it one more time real quick. Select the eve line. That's the eve line. That's the setback
Yep,
truss.
that's the step back truss line. Yep.
That's
Yep.
the roof edge. That's that one.
There you go.
Beautiful. And how does that import into?
Just as steel members, they look like little beams.
Okay.
And they look like truss, and they'll get analyzed.
But I need to convert this truss to a gable truss in design, right?
It'll come in as a gable.
Oh, it automatically knows
As
that?
long as it's set, as long as it's on a continuous bearing, it'll be fine.
It should automatically know that?
Yeah. So you gotta create all your connectivity first before you do anything.
Right. Okay. Connectivity. Oh man, I selected the wrong thing.
Click user defined scope.
Label by
Now
select.
you'll see all of it have. Yep. Then
Right.
label them. Then label them.
Yeah. Label selected trusses.
Yep. Then hit design selected. Yep. Current. Yeah. There you go. You can always say unlabeled only too.
Okay.
So if you click unlabeled only, it'll only put labels on trusses that don't have one.
Got it. Design selected.
Says there's a collision someplace, so
OR2
it's got some kind of a
and GE
interference someplace, but it could be up there. OR2, OR6. You can click proceed if you want. There'll be little circles where it's at. Yeah, just hit start.
So that's our gable truss.
Yeah. Yep.
I don't see the loads on it, but I assume it's in there.
It kind of knows it's there. Well, essentially, it's not, doesn't need to be loaded because it's taking that load and sending it right down to the wall,
Yeah.
technically.
Yeah, a lot of times I just use my panelization software to model these.
Oh, okay. That's fine. That's up to you, but this is how, because you have to drop these. So 4 of them, but you can put them in here.
Right. All right, and so that's just all those little pieces.
Yeah, that's all.
Engineered connection required, okay. Will it automatically recommend a connection?
No.
Oh, RF2 is that the fascia thing.
Oh,
The rake fascia, right? RF1
that's
and RF.
RF2's over there.
Yeah. So let me go to OR5 and see if that one will generate.
Yeah, that's fine. It generated.
All
There's
right.
just not much to it.
But this engineered connection detail is something we can get from you, right? A standard detail.
I think there's a standard detail on the website. Yeah.
All right.
Cool. All right, guys.
All right. Thank you so much, Gary.
Oh, you're
I'm
welcome.
sure we'll have plenty of questions whenever
Yeah.
we run into things. But until then, thank you.
Oh, you're welcome. You guys have a good rest of your day.
All right.
All right. Thanks.
Thanks. Bye-bye.
Nice to meet you, Gary. Bye bye.
It was nice to meet you guys too. Bye.
Bye bye.